In this video, we'll cover what happens when you click on a button in a frame. So we've talked about how frames are just simple open graph tags where there's a server that has some metadata, and when this metadata gets to the client, it gets turned into an image. And in the case of frames, there might actually be some buttons associated with the image. So when you're using an app like Warpcast, there's usually a backend, the Warpcast backend in this case, which will cache a copy of the frame so that it doesn't have to go back to the server every time, and it will deliver this cached copy down to the user's device so that the user can see the frame. So this is all very standard. It's how Open Graph works. Where things start to get interesting is when people start clicking on the buttons. So there are a couple of different types of buttons here. So the first one is a very simple link or redirect button, where you may just redirect someone to a website, or in the future, perhaps you'll even be able to redirect someone to a wallet where you can say things like mint NFT and give it an address, and the wallet will be able to go and execute this transaction. But these are very straightforward. They're just saying, hey, link me out to a different app like a browser or wallet, and then I'll go do something within that app. The more interesting applications of frame servers is when you send a response from the frame back to the server, telling it that you clicked an action, and the frame server then does something interesting based on that action. For example, if this was a shopping cart and you were checking out and the frame server knew that you were a repeat customer, it might give you a special discount on the purchase. So a simple way to do this would be, well, you just send the response, the button you clicked on. So say Alice clicked button 1 at time t, and a bunch of other information about the action. And you just have the frame server, or you just have Warpcast backend send this all the way back up to the frame server. So this, we'll call it this action, makes its way back up here. The problem with this approach is that this isn't authenticated. And so anyone can push to this frame server saying Alice clicked button 1 and take advantage of that discount that we were offering, which isn't ideal. You actually want to know that this came from Alice. So frames actually implement a system of authentication using Farcaster's account key system. And we'll talk about that a little bit and then tie it back into how it works with frames. So when you create a Farcaster account and you sign up on your phone, you actually are creating a new Ethereum address or ECDSA key on your phone, which is an address on the blockchain and also owns your Farcaster ID. So this key is used to create your Farcaster account. It's used to transfer your Farcaster account or recover it, and it's very rarely used for other things. For the most part, it's just this high-level key that's used to control things that lives safely on your phone and is never used in the normal flow of things. Now, when you want to post from an app like Warpcast, you still need those messages to be signed. And so the way this works is there are keys known as account keys. So an account key is an EDDSA key pair, which is a key pair that can sign messages but can never hold money on the Ethereum blockchain. And the ECDSA key pair sets up an EDDSA key pair. So when you create your account and you say, I want to use Warpcast, Warpcast generates a new EDDSA key pair and says, hey, I'd like to use this to sign messages on your behalf. And your phone in your account says, great, I trust you. Let me authorize your key to post messages on my behalf. So it does this by posting a message on the blockchain in a smart contract that we call the key registry. And this is established when you first created your account and said, I'd like to use Warpcast. And if you use multiple apps, there's going to be a key for each of these apps that you use. So this relationship is particularly important because what happens now is whenever you send a message back to the frame server, you sign it with this EDDSA key pair, which then creates a signed action that the frame server can verify. And the frame server doesn't necessarily know which EDDSA key maps to which ECDSA key, but this is easily solved because hubs, which run on the Farcaster network, have this deep knowledge. And so what happens is when you click on this action, a frame server can reach out to a hub and quickly call a verify message endpoint, which authenticates this, and then the frame server knows that you are Alice and that you clicked on button B in particular in this scenario. So that's how an authenticated message works end-to-end. And most importantly, this chain of authentication when you click on a frame never touches the ECDSA key pair. That relationship was established previously on-chain and never live during the course of a frame transaction. And so this helps isolation between your Ethereum and on-chain addresses and your off-chain EDDSA addresses, which are used to sign frame actions and prove that you took a specific action.